In this video, we will learn how to find utility maximizing bundle given the utility function and the budget constraint. The question is considering a consumer with the utility function. Utility is a function of two goods x and y, which is equal to x to the power alpha times y to the power 1 minus alpha, where the value of alpha lies between 0 and 1. Find the utility maximizing values of x and y when the consumer faces a budget constraint, that is p of x times units of good x plus price of good y times units of good y, and it should be equal to the m, which denotes the income of the consumer. Okay, so in this question what we have to do, since we have the utility maximizing problem, that means we want to maximize the utility of the consumer, which is equal to x to the power alpha times y to the power 1 minus alpha. Okay, or let's say a here, subject to the budget constraint that he is facing. The budget constraint is being given us, that is price of good x times units of good x plus price of good y times units of good y should be equal to the income of the consumer. Okay, so graphically what exactly is meant by this? So if I draw a simple graph here, so we have x on the horizontal axis and y on the vertical axis. With the given budget, this budget, consumer's endeavor is to maximize his utility or maximize his satisfaction. That means with the given budget line, consumer wants to reach to the highest possible indifference curve, and optimality happens at a point where the indifference curve is tangent to the budget line. Mathematically, it means it's a point where the marginal rate of substitution between good x and y, it should be equal to the ratio of the prices, that is price of x upon price of y. Now MRS denotes the slope. So the slope of the budget line is actually the marginal rate of substitution, and px upon py, that is the price ratio, it shows the slope of the budget line. So at this point, our MRS is equal to the price ratio, price of x upon price of y. MRS, as we know, it is equal to marginal utility of good x upon marginal utility of good y, and it should be equal to price of x upon price of y. Now MUX means the change in the utility due to the change in the consumption of good x. MUY means the change in the utility due to the change in the consumption of good y. It should be equal to price ratio. The partial derivative of utility function with respect to x gives us du upon dx. So partially differentiate this with respect to x. So the exponent of x becomes coefficient. So we have a x to the power, and exponent is subtracted by 1, a minus y 1, and y to the power 1 minus a remains same because we are taking partials with respect to x. Similarly, in this case, du upon dy means the partial derivative of this function with respect to y. The exponent of y becomes coefficient, so exponent is here 1 minus a, x to the power alpha remains same, and we have y to the power 1 minus a minus 1. Okay, because exponent is subtracted by 1 by power function rule, so it should be equal to price of x upon price of y. Okay, so here 1 and 1 gets cancelled. Okay, let's do one thing here. We transpose, or if I rewrite here, what will we get? So here we are left with y to the power minus alpha. Here we have x to the power alpha. If I transpose y to the power minus alpha to numerator, its exponent sign will change. Okay, and I will transpose x to the power alpha minus 1 to denominator. Again, the exponent sign will change. So we have a divided by 1 minus a. So we have y raised power 1 minus a, this, and transpose it, it gets multiplied, but exponent sign changes. So we have y to the power minus alpha, it becomes plus alpha. Okay, divided by, here we have x to the power a, transpose this to denominator, it gets multiplied, but exponent sign changes. So we have x raised power a minus 1, it becomes x raised power minus a plus 1, and it should be equal to price ratio, p of x upon p of y. Okay, which implies Here bases are same. We have y minus, and here if I write y 1 minus a plus a, so minus a plus a gets cancelled. In the denominator we have x, bases are same, we can add the exponents. We have a minus a plus 1. This gets cancelled, this gets cancelled, so we get y upon x only in these two terms. Okay, I am doing this because to save the space. So here we got a divided by 1 minus a. Okay, I am using alpha and a interchangeably. I am getting confused. So a and alpha are same here. So here we got y upon x. It should be equal to px upon py. Okay, solve for y if I have the space. I don't have the space, so let me rub this now. Solving for y means y will be equal to we have px upon py. If I transpose this, it becomes 1 minus a divided by a. Okay, it gets transposed but reciprocated times x. This is the value of y. Now we need to plug the value of y in the budget equation. Okay, so we have price of x times x plus price of y times the value of y is this very stuff, that is price of x upon price of y times 1 minus a divided by a times x should be equal to the income. Okay, so py gets cancelled. Here we are left with, we have x, or if I rewrite it, so I have to be very cautious. I don't have the space, so let me make some space. Okay, so we have p of x into x plus, then we have, here we have 1 minus a divided by a times p of x into x should be equal to m. Let us take p of x and x, p of x and x common, so we are left with p of x into x, and here we are left with 1 plus 1 minus a divided by a should be equal to the income. Okay, so let us further solve it. So it becomes cross multiplying. So we have p of x times x. Here we are left with a plus 1 minus a plus 1 minus a divided by a should be equal to the income. So a and a gets cancelled. We are left with 1 upon a. That gives us x will be equal to, we have m here. Okay, this a gets multiplied divided by p of x. Okay, this denotes the optimal bundle of good x, or demand function of good x. Okay, here you can see x, that is demand for good x, is a function of income and price. To find out the value of y, what we do, we plug x is equal to this stuff, where do we plug the value of this? So when we solve it, okay, here we have the value of y, so y will be equal to, y is equal to price of x divided by price of y times 1 minus a divided by a times the value of x that we got here, that is a times m divided by price of x. Solving further, price of x, price of gets cancelled, a and a gets cancelled. That gives us y will be equal to 1 minus a times m divided by price of y. This is the demand function for good y. That means that is the optimal bundle. So our optimal bundle will be, So our optimal bundle will be AM upon PX and 1 minus A times the income divided by PY. This is our optimal bundle. I hope I make myself clear in this video. Thank you.